Hey, what's going on, guys? Let's do this problem right here. Here this question is asking for the temperature with time, and we know this delta T is going to be temperature with time minus 0 according to this diagram, and let's see how we can find it. First of all, we know that Q dot is equal to K delta T over L, and Q dot can be represented by dQ over dt, and we know that dQ is mc delta T, right? So mc dt. Let's replace this dq with this value and see how we can figure out this t time. So if I replace this one with this is going to give us mc dt over dt. That's equivalent to ka delta t over L, right? Now what we can do is we can arrange like terms together, and also instead of writing this delta t, we can write t minus 0. So t minus 0 is going to be t, so we can just write t right here instead of writing delta t. So this is going to be t, and if I rearrange this one, this is going to be dt over t. I'm rearranging like this because it's easy to integrate if you have like terms together. So here we have dt over t, and I can move all the others to the other side. Here we are going to have ka dt over mcl, right? This is small t, time. And now let's do the integration. dt over t, and this is going from initial temperature to whatever the final temperature we have, right? So initial temperature to final temperature. In the other side we are going to have ka over mcl, and we can integrate this time dt, and this time is 0 to whatever the time it is. So this is going to be 0 to t. Now if I do the integration, 1 over t is ln t, so this is going to give us ln of t. Now let's write this one with different color. Here we are going to have ln of t, and that's going from t naught to t. And in the other side we are going to have ka over mcl, and if we integrate this dt, that's going to give us t, and that's going from 0 to t. Now let's apply these limits. So first we are going to have ln t minus ln t naught, and that's equivalent to ka mcl, and if I apply t, this is going to be t, but if I apply 0, all the things are going to be 0, so we don't have to write that one. This one we can express as ln. So when ln subtract, it's mean dividing, so this is going to be ln t over t naught, right? So this is how the expression is going to look like. But as you can see from the diagram, initial temperature is going to be the hot temperature, right? So as it moves toward this direction, the temperature is going to be less, so the top value is going to be less, so the total ratio is going to be less than 1. So whenever we have the ratio less than 1 in ln equation, that's going to be a negative number. So what we can do is we can move this negative to the other side, and we can take absolute value right here. So let's take absolute value of this one and take the negative sign to the other side. So here we can have negative ka mcl t, and if I take absolute value right here, this is going to be absolute value of this one. Now we have this one. Now to get rid of this ln, what we can do is we can take e power. So if I take e power, this ln and e cancels, so we will end up with t over t naught. So let's write in terms of e power first and then cancel, right? So here we're going to have e power ln t over t naught. That's equivalent to e power negative ka over mcl times t. Now here this e power and ln cancels, so we are going to end up with t over t naught. Now let's write the final expression. We need some space right here, so let's continue this one right here, right? I write with different color. So here we are going to have t over t naught, that's equivalent to e power minus ka times T over MCL. KAT over MCL. So this is going to be our equation, but the thing we are trying to find is T times, right? T time is this one, the top one. So temperature time therefore is going to be equivalent to T naught time e power minus KAT over MCL. So that's going to be our final answer. I hope you guys find this video helpful. See you next time.